Hey everyone, and welcome to this special pitch explainer. Today, we're basically stepping right into the evaluation room. So for those of you acting as our virtual judges for the World Food Day 2026 Youth Innovation Challenge, well, get ready because we are breaking down a truly fascinating submission. We're looking at a project from a team called Silicon Agrotech. It's led by Kalana Pereira and Thusithra Kajathipan out of the University of Colombo. Now, their ambitious pitch is called KRUSHI IAPS, which stands for Agricultural Intelligence Platform for Sustainability. It's this bold, tech-forward approach aimed at solving one of the absolutely most critical issues of our time, sustainable soil and water management. I'm so excited to guide you through this, so let's just get right into it.
Okay, let's dive into this because there's this really incredible paradox in our modern world. Think about it. Right now, there are massive amounts of satellite data, weather metrics, and these incredibly complex climate models just floating around in orbit and sitting on servers. But despite all that literal space-age technology, a smallholder farmer in Sri Lanka is still standing in their field, looking up at the sky, wondering this exact question: what action should I take today? It's honestly a bit absurd, right? We have terabytes of environmental data being generated every single second, yet the actual person growing our food is left guessing whether they should open the irrigation gate today or wait until tomorrow.
So the crucial point here, and Silicon Agrotech hit the nail on the head with this, is that the problem is absolutely not a lack of information. We have plenty of that. The problem is a massive translation gap. There's this huge disconnect between complex environmental data and ground-level farming realities. It's like a giant puzzle where the pieces don't quite fit together yet for the user. Farmers don't need a spreadsheet full of atmospheric pressure readings or raw satellite imagery. They need a system that cuts through all that noise and gives them a simple, reliable, and actionable agricultural decision.
And man, the need for those clear decisions has literally never been more urgent. Smallholder farmers in Sri Lanka, we're talking paddy farmers, vegetable growers, they're facing a daily onslaught of severe, climate-related challenges. Highly unpredictable rainfall patterns, brutal extended drought periods, really severe limitations on water resources, and escalating risks of soil degradation. You know, for generations, farmers could just rely on traditional knowledge and seasonal experience, but climate change has completely shaken that up, introducing a level of uncertainty that makes traditional methods, and honestly, even general weather forecasts, practically obsolete. The stakes are simply too high for guesswork.
Section 1. Introducing KRUSHI.
So this brings us to the solution space. How exactly do we bridge that massive gap between high-level climate data and the daily struggles of a smallholder farmer? Well, let's look at the innovative approach Silicon Agrotech brought to the table. The core technology they're using here is called an agricultural digital twin. Now, I know, that sounds like some heavy startup jargon, but let's demystify it right away. Essentially, this tech creates a digital mirror of a farmer's physical field. It takes satellite data, weather APIs, drone imagery, and local field info, and weaves all of it together to build a highly accurate virtual representation of that specific farming environment. It's like having a high-tech simulation of your exact farm running in real time in the cloud, constantly tracking your specific soil conditions and water availability.
But here's the kicker, and where the Silicon Agrotech team shows they really get their end user. Having a high-tech simulation is completely useless if the farmer can't actually access it or understand it. In major agricultural districts, places like Anuradhapura, Polonnaruwa, Kurunegala, many middle to older age farmers just don't have a ton of smartphone experience. So this technology is specifically engineered to bypass those literacy and tech barriers. It's built for super simple interaction, using native Sinhala and Tamil voice guidance. It literally speaks to the farmers in their own language, giving practical recommendations without making them navigate some complex menu or try to decipher a technical chart.
Section 2. How the platform works.
Let's shift gears a bit and actually look under the hood. How does this platform get from raw data in the cloud to a voice telling a farmer exactly what to do? Well, the system operates on a really seamless four-step journey. First up is data collection, so gathering all that multi-source environmental info. Step 2 is taking that raw data and creating the agricultural digital twin, that digital mirror we just talked about. Step 3 is the agricultural intelligence analysis, which is where the system crunches the numbers on rainfall patterns, soil moisture trends, and water needs. And finally, step 4, which is kind of the magical part, outputting practical recommendations. It translates all that heavy back-end processing into a single, straightforward farming decision.
And this perfectly illustrates exactly what that translation looks like in practice. Think about the complex data existing systems provide, like rainfall probability is 85% with 30 millimeters expected precipitation.
I mean, to a farmer standing in a field, that just forces them to do mental math about their soil drainage and current moisture levels. But contrast that with the KRUSHI IPS output. Rain expected, your field has enough moisture, do not irrigate today. Boom. It takes all that statistical noise and turns it into an immediate, actionable instruction. It prevents over-irrigation, saves precious water resources, and entirely removes that cognitive load from the farmer.
Section 3. Decisions, not just data.
This is what I love about this pitch. It completely shifts the agricultural tech paradigm from just delivering data to delivering actual decisions. It's a classic startup us versus them comparison. If you look at existing IoT smart irrigation or satellite platforms, their core value is usually just providing data. They're very technology-focused, and they spit out general recommendations that require a decent amount of technical understanding. KRUSHI IPS flips this entirely. Its core value is providing decisions. It is deeply farmer-focused, it offers field-specific guidance, and it uses beautifully simple communication. It doesn't overwhelm the user, it actively guides them.
To pull this off, the platform cleverly uses a dual interface strategy. So, for the macro view, you have the Agricultural Management Dashboard. This is for researchers, agricultural organizations, and government agencies. It provides digital mapping and regional risk monitoring. But then you have the farmer interface. This is that simple, voice-assisted tool giving daily recommendations and weather alerts directly to the smallholder on the ground. This dual approach makes the whole system incredibly valuable for both high-level regional planning and micro day-to-day execution.
Section 4. The path to implementation.
Now, as judges for an innovation challenge, you are probably asking the million-dollar question right now. Okay, but is this actually feasible in the real world? Well, their model delivers a total knockout punch to any concerns about capital efficiency. The platform requires zero expensive hardware installed by the farmer. None at all. They don't have to go out and buy costly IoT soil sensors or mini weather stations for every single field. Because it leverages existing satellite data, publicly available weather info, and scalable digital infrastructure, the barriers to entry is kept incredibly low. It is a highly practical, incredibly capital-efficient solution tailor-made for smallholder farmers.
And to prove they're ready to move, the team has a really concrete and rapid prototype development plan. It's a tight, focused 2-month sprint. Month 1 is entirely about developing the digital twin prototype and doing the farm mapping for a selected pilot area. Then, Month 2 pivots directly to developing the user interface, integrating that vital Sinhala and Tamo voice guidance and putting it through rigorous usability testing.
Beyond just that initial prototype, their wider pilot implementation follows a very smart, measured 3-phase approach. Phase 1 focuses on selecting a specific agricultural region to map out the farms and collect a strong baseline of data. Phase 2 is all about building out this visualization and prediction dashboards, and crucially, Phase 3 is completely dedicated to validation, actually measuring the real-world water usage improvements, checking the accuracy of the system's recommendations, and tracking farmer acceptance before they ever try to scale up through government or regional networks. It's a validation for strategy, and honestly, that's exactly what you want to see.
Section 5. Empowering tomorrow's farmers. As we zoom out to look at the ultimate impact this project aims to achieve for the future of agriculture, what we're really looking at is a fundamental transformation pipeline. KRUSHI AIPS takes raw data collection, elevates it up into deep agricultural intelligence, and then distills it all the way down into practical farming decisions. By creating this seamless flow, the platform has genuine potential to severely strengthen Sri Lanka's agricultural and environmental resilience. It ensures smarter soil and smarter water management in the face of an increasingly unpredictable climate.
I want to leave you with this final, incredibly powerful closing statement directly from the Silicon Agrotech team. They said, KRUSHI IPS is not designed to replace farmers. It is designed to empower farmers with better knowledge, better timing, and better decisions for a more resilient agricultural future. It is such a brilliant reminder that technology is truly at its best when it serves the human element. The goal here isn't just automation for the sake of automation, it's about giving hardworking people the exact tools they need to thrive in a rapidly changing world. So, virtual judges, the provocative question isn't whether this technology works. The real question is, how quickly can we get this intelligence into the hands of the farmers who need it most? Thanks so much for joining me on this explainer, and I'll catch you on the next one.